So we're going to just go over quickly the solution for this, and then we'll play around with Kotlin some more. I'll just minimize my device manager. So I'll go ahead and create a new project. And I'll use Kotlin. I'll just accept my API level of 23. And I'll just go into our my activity main. And maybe I'll get rid of my text view that's here, my hello world. Just have to wait till Gradle's done building my project before I can jump in. Actually, I guess I could even start in here. Well, maybe I'll wait for this to be done. It is not the world's fastest IDE. I think we can safely say that. So I'll go into design view and I'll just grab some controls. So I will grab a plain text and I'll grab a password. Actually, maybe I'll grab a button. So I'll just drag those on. So I'll call this edit text username. We'll call this one edit text password. And I'll call this one button login. I'll use camel case because that's what Android prefers. And then we can start with our constraints. So for my username, I'm actually going to go in here and maybe we'll set up first a top constraint. What should I constrain the top to? I am. Yes, thank you. And I think I actually have my audio working. So thank you. Yes, audio is working. I forgot to click this last week. And if I don't click it, my audio doesn't get captured. But I am streaming. Thank you for reminding me. So what should I anchor that to? Yeah, we'll anchor that up to the parent. And maybe I'll anchor my right to the left of my password box. So I'll have a username on the left, password on the right. We can do the same here. So our password can also be to the parent. And our left will be to the right of username. We'll see how that looks. And maybe we'll put our button, oops. We'll put the top to the bottom of password, and I'll put the bottom to the bottom of parent. There's different ways you can constrain them. This is not the only way to lay it out. And I'll maybe center my button horizontally so left and right can go to the parent. Again, if you've used different constraints, no problem. That's fine. We'll just see how this looks. Actually, I'll just run it. I may have to change my constraints a little bit more. We'll want to put some text on the button. We'll use a string resource. So our button says login. We'll see how this looks in the emulator quickly. Actually, while I do, I can set up the text property of my button. We've got a warning that it's hard-coded and says the word button on it. So we'll do it properly with a string resource. So I'd like to, my Android Studios. We'll give it a minute, hopefully to come back to life. By the way, there's a useful window here that a few of you, when you were getting errors, this Logcat button, this shows you a log. Now it shows you a ton of stuff. It defaults to the verbose option, meaning show absolutely everything. So it prints out statements one after the other. If you just want to see the errors, which I can't do because my Android Studio is frozen, you click Logcat and there's an option to change verbose to error. And that will simply show you the log of any errors that are happening. Awesome. All right. Well, is the rest of my computer frozen? No, just Android Studio. All right. I guess I'll restart it. All right. Actually, while this is syncing again, I can try to change my text to use a string resource. I can do it through the designer or through the XML view. If I change my text to say @string login and then hit Alt-Enter, I can't do anything because Android Studio is. Or or I can just manually go into my strings.xml and create a new string here. So we could use the wizard through this for the visual designer, or we can just do it manually, create the XML node, and then reference this string resource with @string and the key name. Okay. We shall try again. So I could probably add some hints here. So my text box, it defaults to saying name. I'm going to get rid of the text property. And instead, I'll set the hint property with the string resource. So I'll just add a new string resource here. The ID is not being very kind to me today, is it? Come on, you can do it. Try that again. There. So I'll call this one the resource name, all in lowercase, is username. And the value will be username. And I'll do the same for password. I'll set up a hint. And I'll apply those changes. My UI is a little funky. I think I might need to move my text inputs down. Some of you may have stacked them vertically with the username on top of the password. If you did, that's perfectly fine. So I'll probably want, I don't think I put any top constraints on these. I'll want a top constraint. If I constrain them to the parent, that should slide them down. So here's my Logcat that I was describing. If I go here and pick error, I can see any errors. We'll try to apply those changes. Oh, I have to restart. I can't just apply the changes. So I'll restart it. So now I can see my hints here. Okay, so we're almost there. I just need to add a couple of top constraints. Will be the last thing. So I will add. I've added top constraints. I haven't added any bottom constraints. So I'll maybe put these above my button. So I'll say our bottom is to the top of my login button for both username and password. I'll just copy that constraint. And apply those. That should hopefully shift my username and password buttons, my username and password inputs down. All right, good enough. Again, you may have positioned things differently. That's fine. If I rotate my device, I guess we could anchor them as well, the left to parent for username and right of password, and that way they'll shift over and be in the center of the screen horizontally. So I will add one more constraint. So my username left will be to left of parent. So we're just kind of experimenting with the constraints. We have to play around a bit. So my username will be anchored left. My password will be anchored right. And then I should be able to rotate the device and those things should stay centered horizontally. There, so they're in the middle. If I rotate my phone back, all right, we could add margins if we want. It's good enough for now. So now that's basically my UI. So what did we do in here? A number of you have this working. So what's the first thing we want to do here? What do I need? Okay, so where should I do that? On what line? Okay, and how should I declare? What should I declare and how should I do it? Yep. Yep. Okay, so I'll, yep. That's actually, I think it's colon. That Chad, like this? Sorry? Yes, right? Because that's the name of our. All right, what are we missing here? And where does that go? Okay, now it doesn't find the edit text class. So if I just highlight it and Alt Enter, it imports the edit text class library. So we'll do the same. Now there is a shortcut for this, which I'm going to show you once we get this working, okay? It'll save us some coding. And the same thing. So this is of type button, which also is unresolved. So if we just hit Alt Enter, we get a reference to the button class. Okay, so there are declarations. What do we do next? Okay, and where should I do that? Okay, actually after we set the content view. So after the two boilerplate lines that come auto-generated, we'll instantiate 3 views. So we're now going to connect up our 3 variables to the 3 objects in our layout resource file. Okay. I should just apply those changes to make sure we didn't break anything. And if we did, then we can start commenting those sections out until the app runs again. So nothing will actually happen, but we want to make sure none of this code prevents the app from running. probably a good idea before we finish the whole thing. Since I've got to actually restart it. Okay, it didn't die, so that's a good sign. So what do we do next so that we can actually check the user input? Ali? Sorry? Okay. Yep, so we'll set on click listener. Okay, and what happens in that on click listener? Okay. Okay, we could, there's multiple ways. What would be the shortest way of doing it? Sorry? Okay, but if we just want to get the text that was entered in there. So what was the whole line you used? Okay. Okay. Now we don't actually, we can convert it with toString. We don't actually have to. The text will automatically be a string. So the toString is actually optional here. Should run without it. But we can try it and see. Okay. So now what does our logic look like here for our if statement? Do you have it? Did it run for yours? Okay. Yep. Yep. Okay, so what operator did you use? Okay, yep. Yep. Mm-hmm. Yep. Okay. Okay. Okay, well, we could probably, so we could do it here, or we could just set the message and have a single make toast after. So that way we would avoid having to repeat the toast twice, right? So we could just say, if these are equal, our message is welcome. Otherwise, what would message be? Yep. In fact, we could make this even shorter. This would work. How could we make this even shorter? Yeah, we can just declare var message. Let's just initialize it here as try again. Then we don't even actually need an else, do we? The default message is try again unless we get the correct credentials. Then we'll change the message to welcome. So now we can just do our toast here. So we can use this for the context. Okay. So it doesn't like this, so we do need the toString. Sorry, Ali. All right, so let's run this and see what happens. Obviously, there's some different algorithms and different ways you could break this down. Do it like this. Let's run it and see how we do. So if I just click the button, it says try again. If I put in the correct credential, okay, did I put in the correct credential? I didn't use a capital P, so when I put it all in lowercase, I got try again. So if you click that little down arrow, that hides your keyboard. And now when I click login, okay, maybe our logic isn't quite right. Thought I did it correctly, but let's see. I think my username's correct. P. A, S, S. Okay, so our logic isn't quite there. Sorry? Oh, yes. Right, because I've declared the variable again, it's a separate variable, right? Message only exists within that if block. So when I moved this up, thank you, Priyanka, I was redeclaring my message as a block level variable instead of using this one. So nice to have such a smart team to debug. Can you guys come with me when I write all my code? It saves me a lot of time. I actually had a student last semester say about another instructor, the instructor hates when we point out they've made mistakes. And I thought, I don't know how I would ever get through a class if I didn't have you guys pointing out my mistakes. Okay, this should work better. So I can also just use my physical keyboard, which would probably be better than trying to use my emulator keyboard. Would be smarter. There we go. So I get welcome. If I change the password, I get try again. So thank you for the coding suggestions and the debugging. There's our simple little app. Okay. Does anybody have questions about any of the code that's here? Or about anything I did in the layout with the constraints? I do have a small piece of good news for you, which is this is the last code sample we're going to have to write where we have to declare all of the individual views separately and use find by ID to instantiate the instances of them. This for a long time has been a big complaint of Android developers. So Kotlin has a number of extensions, and one of these extensions will automatically handle the work we're doing here in this section with the variable declarations as well as the instantiations with find view by ID. So on Blackboard, there's a line of code that we're going to use. So if we import this line, there's a Kotlin, it's called Kotlin synthetic. We can maybe pull it up for a minute and have a look at what it does. Excuse me. So Kotlin has a number of extensions. So we use, normally we need find view by ID to find anything from our layout. But Kotlin synthetic, it will do all of this binding for us automatically. All we have to do is import this library, and then we'll no longer need find view by ID. So this is going to save us. So the extension has some other properties. We've got caching, which may be useful for performance. There's a number of other things it can do. So I'm going to grab this line from Blackboard. I'm going to paste it up here. Maybe I'll make a comment here. We're going to add the synthetic extension to automatically bind all views. So once we do this, this is no longer required. And same here. So I'll actually copy this comment here as well. So notice Android Studio still is letting our code. It's not showing any errors once we've got the synthetic. Actually, I'm curious if I exclude this, right? Without the extension, suddenly it no longer knows what our login button or our to edit text are. They immediately turn red. They're undeclared objects. But once we do this, we bring it back. Android Studio goes, that's fine. Synthetic does the binding for us. So if I want to rerun the app, it should run in exactly the same way. We'll just test it and make sure we still get the same try again or welcome response. Now I wanted to show you, actually we'll make sure it works first before I say anything else about it. So I click login, we get try again. If I put in a valid credential, everything's still working. Obviously, when we can import one line of code and remove 6 lines of code, that's always a good thing. I did want to show you this, however. I wanted us to use this form of having to declare and use find by ID for a couple weeks for 2 reasons. Number one, this is the default. So if you don't bring in the extension, this is the expected behavior that we have to declare and use find view by ID for everyone. The other thing is, because this find view by ID syntax has been around for so long, if you're looking at tutorials and you're looking at code samples online, chances are, especially if they're Java, this is there's a separate Java extension that will handle this, but a lot of the code samples you see, they're going to include find view by ID. So if we just added the extension right from the beginning and never used it, you might find all of those find view by ID lines confusing if you're looking at a tutorial or somebody else's code. When I taught the class last year, we did use this for basically the entire class. In Java, there's a library called Butterknife. It's an extension that does a similar thing. And I always meant to get around to showing the class how to use Butterknife, and we never got around to it. I put the link somewhere on Blackboard in the lessons, and I always forgot to find the time to do it. So my students unfortunately wrote find view by ID a million times through the semester. I'm saving you guys the pain of doing that. So we do need this extension. We'll need to put it in every activity. We can look and see if there's a way to do it globally. I haven't honestly tried. I'm sure one of you smart people will probably figure that out before I do. So if there's a way we can import it globally so we don't have to bring it into every activity, great. If not, we'll make sure every time we create a new activity, that'd be the first thing we do. So that will avoid us having to use find view by ID and declare all our views. Okay. Does anybody have any other questions about this little exercise or using this synthetic library? Okay. So if not, what I'd like to do is just play around a little bit more with some of the kind of basic Kotlin features, just so that we get a little more familiar with how Kotlin works, and also so that we can take a kind of a careful look at some of the differences in how it behaves and how we'd code it from writing equivalent Java code. Okay. So what we'll do is we're just going to actually use a unit testing project so we can write some code, and we're not going to do any UI design. We don't have to run anything in the emulator for this. We'll just try some functions out, some basic Kotlin functions. So I'm actually going to stop my emulator because it'll save my RAM. So over on the left in our project, in our Android view, if we expand the Java folder, we've actually got we've got 3 projects. So this one that says lesson 2, that's the main project that contains our main activity. And then we've got this test. So if we expand this, I'm going to actually create a new Kotlin file inside of my Java folder that says test. So I'll just right click it and say, we'll just create a new Kotlin file or class. So again, you can see the path. Just right click the test folder, choose new, and new Kotlin file. And we'll call this file, we'll create a few different ones. Let's call this one variables. We don't need to give it a .kt extension. Android Studio will automatically assign it because we've said it's a Kotlin file. If you name it something else, no big deal. So in here, we'll create it as a test class. So I'll add the decorator test, and that will import JUnits. Unit testing class, you guys have used this before. That'll just allow us to run particular methods in here and see if they pass or fail. Okay, so let's look at how this works. Let's create a function with the fun keyword, which comes up. Let's call this one read only. So let's declare a variable. What's your favorite flavor of ice cream? If I was going to buy you ice cream after class, what would you order? Ron? Okay. So we're going to declare the variable and we're going to assign it a value. Notice what happens. Let's say somebody says, who in here doesn't like cookie dough ice cream? Okay, what do you prefer instead? All right, both good choices. So notice what's happened here. Why do I have an issue on line 11? We declared it and assigned a value, and then we've tried to change that value. Yeah, when we use val, it's basically immutable, can't be changed. Right? So this is not going to compile. If I try to run this test, We can try to run our unit test here. It's probably not even going to run because we're going to get a build error. Right? So we cannot use val. So in order to get this test to pass, we're going to have to comment that out. We can't change val. In effect, val is our constant. So it should run now and pass. So we'll just add a note here. We can't reassign the value when something is declared with val. So let's try a second one. So each of these functions will declare with test. So that way we can run them. So we'll call this one mutable, meaning something we can change. So if we want to basically do the same thing here, we couldn't do it in our read-only function. We couldn't pick cookie dough first and then reassign that value. How could we rewrite that test so that it will actually run, where we can set an initial value and then we can change it? We'd have to change one thing from that first unit test. Ali? You got it. So instead of using val, we're going to need to use var. So we can declare it with one and assign one value. So one character makes the difference. That val is constant, var can be modified. So basically a constant versus a variable. So we could actually run all the tests if we want. Okay, so both are test pass in this case. So that's one thing to keep in mind, right, is just being clear on, are we declaring things with val or are we declaring them with var? If we do not want the value to be changed, we'll use val. If we want to be able potentially to change the value, we should use var. So constant versus a variable. Fairly straightforward, I assume, val versus var, constant and variable. Okay, let's create another class. We'll play around a bit with functions, a little bit more. So I'll call this file functions. So above my unit test class, we're going to create a function with the fun keyword. So we'll do a simple multiplication function that takes two integer parameters and returns another one. So the syntax in Kotlin for creating a function is slightly different than what we've seen. So let's have a left function. That's an int, so we do it this way. So it's the name of the parameter, and then a colon, and then the type, as opposed to the data type, space, and the name of the parameter. So different syntax. So I'll declare a left and a right parameter. And also our return type, rather than coming rather than the return type being in front of the name of the function, it's actually at the end, prefixed with a colon. Means the same thing, just a different structure from what we might be used to seeing with the Java function. And then we've got our function body here. So now we're just return left times right. So we're going to set this up and then we're going to write some different unit tests to look at how do we invoke this in some different ways. So just for reference, I'll add it as a comment. Let's rewrite, what would this method look like in Java? Let's write a version of it. We'll call it multiply Java. What would the syntax look like? Yep. Okay, and what would the syntax be exactly? Yep. Yep. Okay, what about the return type? Where would that? Sorry? So what's missing here? Why is it not liking my syntax? So we should be able to write Java code in our Kotlin file. Sorry? They are all I have capitalized them. Should be small. Yep, so our parameters. You know what, it could be, we should be able to. Well, you know what, we'll leave it here. I'll comment it out for now. But at least we can see the syntactical differences between the Java structure of setting up the function and the Kotlin version, right? So syntactically quite different. Okay, so let's write a unit test here. So we'll create a function. First thing we want to do is just call the multiply function, pass in a couple parameters, and print out the result. So we can use print line, where we call multiply. So this should, if we run our test, this should call our function and return can just run this. So this is the simple way to invoke the function and pass parameters, our parameters to it. What did we do wrong? Unresolved reference. Let's see what happens if we put this. I don't think this has to go inside of our class, but let's just see. Let's see. Okay, so that's not our problem. Let's go here. Now I'm really confused. Let's see if I build. This function shouldn't have to go inside of our class. Should be allowed outside. I'm just going to do a build and we'll try and figure out what's going on. Okay, so I can build my code. Imported JUnit class. Okay, let's try something simpler. We won't call the function. I'll just try logging out a string message here. Sorry, I'm going to try running. Or I'm going to copy the other function. You figured it out? Yep. In here. Right. It's right. It's the actual class name because I called it functions. Okay. Okay, so if I call this function test, perhaps, you're saying the class name? We'll see if that. Annotation. I'm confused about this one. So yeah, the error is in here. Okay. I'm going to try this. I'm going to copy this to my variables. We'll see if I run everything in here. We'll see if we can call multiply from here. Let's see if I can run it from here. And maybe I'm just gonna. I notice my functions file doesn't have an extension. I'm just gonna delete that for now. I can always recreate it if I need to. Although I still have the error here. We'll try it. So this. I'm super confused. I can run my original tests, but as soon as I add this one, I don't think I can run it anymore. Mm-hmm. Yeah. Okay. With the functions file? Okay. Let me recreate it. Well, let's do. So let's try this again. All right. All right. Well, try it again. I'll import. And I'll move my multiply function back. All right, we'll try it this way. Okay, seems to work. Thank you, Ron. So again, we commented out this test X in this example instrumented test. I don't even know if we need this file. We may not need it. Okay. So that's one way we can call it. We can also call it this way. We can say we don't have to put past the parameters in their declared order. Typically we want to, but if we want to pass parameter values by name, this should run as well. So it should still be able to multiply them. So our test will still pass if we do it this way. We can also set up default values, as you would imagine. So let's say we want to write a default value of 1. We can see what happens if we only pass a single value into the function. That single value should then get multiplied. So I'll call this version call with default. So I'll call multiply and just pass in a single number. So I've declared the right parameter, defaulted it to 1. So it prints out, gives me oh, I forgot my print line statements here. So if I pass in a single parameter, by default, it passes it in as the left. I forgot my print line statements here. I was wondering why we didn't actually get any output. So we'll add our print line statements here. And run the whole class. And it should print out 6, 8, and 6. Which is what we get. So left and right right and left. And then if we pass in a single parameter, it uses the default value in our function. Let's try a couple of other. Yes. Okay, did you add a default value into the function? That's why. I've defaulted the right parameter to be 1. So I added that into the original version of the multiple. We didn't have that originally. You can see I've highlighted in blue. So you can set a default value there. Yep. The test itself would be in a separate file, much like in Visual Studio, how we have a separate unit test class for each controller. It would be the same. Well, we're not so much working with the, we would have to import, I believe it's this way, Vlad. Here. If we import main activity, we now have access to the classes in there, the objects in that class. Yes, yeah, that's right. We may or may not have time to cover that in the course. If we do, if we have some time, remind me later in the course, okay? So that would, I'll just add. Okay, I'll just leave that reference in there. We're not using it for today, but at least you see that it's there. It's a good question. I'm glad you brought it up. Okay. Let's actually, the other thing I wanted to play around with was actually dealing with some null pointers. So some of the stuff that would throw errors in Java. It's one of the big differences with Kotlin. So let's maybe look at a couple of other tests here just to play around with that. So let's create a function called cannot be null. And let's look at how this works. So we'll use our flavor variable again, but we'll use it as var, not as val, so it can be changed. Somebody else want to give me another flavor? What other flavor do you like? Okay. And actually, we'll declare this one specifically as a string. So now, if we want to wipe that value out, so notice, if we declare it as a string, we cannot, once we populate that variable, we can't set it to null. This is not going to compile or build. Null cannot be a value of non-null type string. So we're not going to be able to do this. So let's write a second version. This one we'll call it can be null. So what would we have to do? We'd have to do something different with this variable declaration. We comment this out because it won't build. How could we rewrite line 27? So after we assign a value to that variable, we can then change it to a null value later. We have to make one small change. Ali, you can take a guess. Yep. Okay, so what would it look like? Good guess. That's actually not where the question mark goes. Nope. Angeli? So we're saying it's a string that's nullable with the question mark, right? It can be a string or a null. If we declare it this way, now, so this is one of the key differences. In Java, this code, I believe, the Java equivalent, I believe it will compile. The problem is at runtime, this line will throw a null pointer exception. So it'll build, but it'll fail at runtime. With Kotlin, it won't build. So a user's not going to get a null pointer exception because that code's never going to be allowed to compile in the first place. So this is kind of one of the big benefits of Kotlin and where it will save many of those runtime null pointer exceptions that we might get in Java. Java is going to allow us to code this, but it will fail when a user actually executes the code. Let's see if there was another one, another example. Yeah, okay, let's try one more. So we can run all these tests, they should pass. Yeah, so everything will pass in this way. So when we're declaring variables, we basically should be deciding when we're coding whether this variable should be nullable or not. We decide that at design time when we're building things, where we can just add the question mark or leave it out, we've got way fewer null pointer errors when we're working with Kotlin. Let's just show you a couple more useful features in Kotlin when it comes to this. So we'll again declare our flavor as a nullable string. Now we can actually check if the value is null or not using the let method. So we can use flavor, question mark dot. And now if we use let, so let's see what happens here. So in this case, it has a value. So let's run this test. So in this case, it prints pumpkin. If we null it out before, Now let's see what happens. Okay, so once we null it out, we can't. So this should tell us, this question mark dot let, it should tell us whether our variable is null or has a value. So we might use that in an if statement, right? Do something if the value is null, otherwise do something else. Yep. Okay, so yeah, that's an alternative, like it's another way of doing it. Okay, true. There's one other operator I want to show you, which is called, and I'm not exactly sure where the name comes from. It's called the Elvis Operators. Anybody heard of this before? Seen it before? All right, so let's try it. So we'll do an Elvis check. We may have to read up for some background on Elvis. So let's initialize it to null this time. So we've got a null variable, and we basically want to say, if it's null, let's give it another value. So let's say we don't want to save null to our database, right? We're asking a user to potentially give us an input, but that input is optional. So if they don't get it, rather than saving null, we want to do something else. So it would look like this. So it's question mark colon. So if flavor has a value, it'll print. If it doesn't, we're substituting this in for that null. So in this case, because the value is null, it prints something else. If we give it an actual value, and I run the test again, it should print pumpkin. In effect, it is, yes. Except the ternary can be used with any kind of condition. Doesn't have to, the condition doesn't have to be, is this value null? It could be like a greater, like we could use ternary with a greater than, for example, right? Or a less than, or some other kind of operator. The Elvis strictly checks nulls. So if the first value is null, we can assign a different value in place of the null. So it's kind of like a subset of the ternary, just simply for null value. But it's the same idea as a ternary operator, yes. And this is a Kotlin specific feature. So you may find use cases where this is helpful. And we don't have this if we were writing it in Java. So there will be some other features kind of along the way through the course that we may discover or implement that'll be different or new. These are kind of some of the common ones that we'll see with Kotlin that will maybe be different or new from how we're working with things in Java. Does anybody have any questions before we go for today? Okay, I just want to have a quick look at next week, what we're going to look at for next week. Did anybody actually take a stab at mocking up an app with the layouts over the week? All right, so next week, what we're gonna get into a bit more, I would encourage you to play around with the layout designer a bit more to increase your familiarity. That's gonna mean you can do things more quickly, right? In the midterm exam, when it's a practical and you gotta design the UI, the more you do it, the faster you'll be able to do it. So what I think we'll do next week is we'll play around a little bit more. We may do a calculator. And we may also look at, I don't know if we'll get into it next week, what happens where we have an app with multiple activities? How do we navigate around? That may be next week. That may bleed in a little bit into lesson 4, where we start looking at intents. I think that's our lesson 4. That's intents. All right, but no assignments or anything this week, no lab. I think my audio worked. I'll push my code up to GitHub. Have a good week. I'll see you guys next week.